welcome everyone. I'm Ethan Knight with Western Water Assessment here at the University of Colorado Boulder. Thanks for joining us today. In today's webinar, we will learn more about the extreme weather events from summer 2021 in the Intermountain West. Next slide. Before we get started, I want to share a bit about Western Water Assessment for those of you who have not worked with us in the past. Western Water Assessment is an applied research program that addresses societal vulnerabilities to climate variability and climate change, particularly those related to water resources. We are based in Boulder and Salt Lake City and work across the Intermountain West, or Colorado, Utah, and Wyoming. Western Water Assessment is one of 11 teams in the NOAA Regional Integrated Sciences and Assessments, or RESA program. Next slide. Our speaker today is Seth Arens, who is Western Water Assessment's Utah-based Research Integration Specialist. Seth will present on the extreme weather events in the Intermountain West from this past summer. The last slide. The presentation will be recorded and last about 20 to 30 minutes, followed by Q&A. Please feel free to submit questions via the Q&A window at the bottom of your screen. We'll be sure to share a link to the recording with you once it's up on our website. And you can follow that link on the screen. And with that, I'm going to hand it off to Seth. Thanks.
Thanks for the introduction, Ethan. So as Ethan mentioned, today I'm going to talk about extreme weather events that happened in our region. So our region is Colorado, Utah, and Wyoming. I'll be specifically talking about and referring to it as the Intermountain West. So this summer, we saw multiple regional heat waves that affected our entire region and large areas of the Western United States. We've also seen the worst drought on record, at least for some of our region, especially in Utah. One very visible impact of this drought is that both Lake Powell and the Great Salt Lake hit all-time low elevations during summer. Wildfire smoke, not from wildfires here in our region, but to our west in California and Oregon, caused severe and prolonged air pollution episodes throughout Utah, Colorado, and Wyoming. A very wet monsoon season led to flash flooding across the region. We saw an extremely wet July, August, and October. Normally, this would cause flash flooding events in a lot of the geography that we have. But in 2020, there were several very large wildfires in Colorado, and this set the stage for potential debris flows from this monsoon season. And finally, I want to talk about how these climate hazards converged in 2021 and introduce the concept of compound hazards. So first off, I want to talk about some of the heat waves that came through this summer, and the first of which was in mid-June. Now, as I'm talking about these data, so I looked at all weather data that's available throughout our region and specifically focused on sites that have greater than 50 years worth of data. And I'll be talking about two kinds of records, one all-time records, so the highest temperature ever set for a location, and those will be the numbers coming up on the map. But then I'll also talk about daily records. So, and I'll have lines that'll say this number of daily records were set, and then in parentheses is a percentage. So that's the percent of sites across that state with at least 50 years of data that reported a daily record high. So on June 15th, and remember, this was when there was a very large heat dome that parked itself over the northwestern United States. Portland, Seattle, southern British Columbia saw all-time record highs, 115, 120 degrees. Our region was kind of on the eastern edge of that, but it still got extremely hot. On June 15th, there were two all-time records set in Utah, including 107 degrees in Salt Lake City, which tied an all-time record, and 106 degrees in Ogden. Nearly 80% of sites in Utah experienced all record daily highs. In Colorado, just over half of the sites saw record daily highs, and in Wyoming, over 80% of sites saw record daily highs. On June 16th, the heat wave continued, and Utah saw two all-time record highs, and about 80% of sites in Utah saw daily record highs. In Colorado, there were two all-time record highs, and about 3/4 of the weather monitoring sites in both Colorado and Wyoming reported daily record highs. And I just want to stress how expansive this heat wave is, that it covered, half to 3/4 of both states in heat that was extreme enough to set daily records all across that region. And finally, on the 17th, an all-time record high of 102 degrees was set in Cortez, Colorado. And about 3/4 of reporting sites in Colorado saw daily record highs. About 60% in Utah and 40% of weather monitoring sites in Wyoming saw daily record highs. Now, moving about a month further into the summer, July 9th through 11th, we also saw another heat wave descend on the region. And this heat wave in general, it wasn't quite as expansive as the heat wave that we saw in early June. We weren't seeing, with this heat wave, we don't see 3/4 of sites within a state seeing daily record highs, but the temperature itself, especially in southern Utah, was more extreme than the June heat wave. On July 9th, Utah set 5 all-time record highs, and Colorado set 3 all-time record highs. 30 to 50% of sites in both those states saw daily record highs. On the 10th of July, there were 9 all-time records set in Utah. And some of those got even as high as 107, 108 degrees. In Colorado, there were 3 all-time record highs, including 107 degrees in Grand Junction. And finally, on the 11th, the heat had kind of receded from Colorado and was isolated to really southern Utah. But Utah saw 4 all-time record highs, and all of these are quite extreme. 107 degrees in Vernal, Utah, 114 at Bullfrog Marina on Lake Powell, 115 in Zion National Park. And in St. George, the all-time record high for the entire state of Utah was tied with 117 degrees. And finally, one more heat wave came through that really just affected Wyoming, July 20th through 21st. On the 20th, there were 2 all-time record highs, including 109 degrees in Warland in north central Wyoming. On the 27th, there were 3 all-time records, primarily in northeastern Wyoming, where temperatures reached 107 to 109 degrees. And then finally, on the 28th, there were 2 more all-time record highs. So to put this heat in context, on a daily basis, it seemed like it was really expansive, very extreme heat. Well, if we look at the entire summer, it really was, in fact, very extreme heat for much of the region. So this figure here shows June through August temperatures for 2021, and it puts temperatures in terms of percentiles. So red means it was the hottest summer on record for those locations, and records for this data go back to 1895. In the orange, it means it was in the top 10% of that 125 years of record. So you can see for much of the state of Utah, parts of northwestern Colorado and western Wyoming saw the hottest summer on record. And almost the entire region, except for far eastern and southeastern Colorado, saw summer temps that were in the top 10%. And overall, averaged across the state of Utah, it was the hottest summer on record. In Wyoming, it was the 2nd hottest. In Colorado, the 6th hottest. And I want to point out the significance of these heat domes that formed over the northwestern United States. And if you look at the whole map here of the western United States, you can see how those heat domes are really often centered more in Oregon, Washington, California, and our region was on the eastern edge of those extreme temperatures. So with high temperatures, often drought is accompanied with high temperatures, especially when there's not much rain. So most of our region has been in drought since summer 2019. Currently, Utah, Wyoming, and western Colorado are in drought, and most of those areas of drought have been going on for 2 years, a little over 2 years, and much of the region, especially in Utah, is seeing extreme or exceptional drought, which is the highest classification of drought. 90% of Wyoming is in some form of drought, and all of Utah is in at least extreme drought. And we really start to see at this point multi-year effects of drought, that we're seeing some impacts to things that affect society. So what are some of the causes of these drought? Well, when you think about drought, really the two major drivers of drought are precipitation and temperature. We've shown that temperatures, at least this past summer, were very warm. Now let's take a look at precipitation. So this figure and the next show precipitation in a similar way as the previous temperature figure. So this shows precipitation from July 2019 to June 2020, so a year period. And it puts it again in terms of percentiles out of the 125 years of records. Orange represents the driest 10% of that record. And you can see most of Utah and a good portion of Colorado and southwestern Wyoming saw below to much below average precipitation for that year period. Notably, there was no monsoonal precipitation to speak of during summer 2019. Now, if you move a year forward in time to July 2020 through June 2021, it was even drier. It was the driest July through June period for probably about 2/3 the state of Utah, some portions of western Wyoming and western Colorado as well. And this was coupled with very high temperatures that we saw, especially early in the summer of 2021. And with thinking about these impacts of long-term drought, something that really started to emerge during this time period, especially during spring and summer of 2021, was extremely low soil moistures. And extremely low soil moistures has impact to several other hazards, several other issues with climate. And one of these is runoff. So we've had extremely low runoff in almost all of our region, except for some of the rivers flowing east of the Continental Divide the last few years have done better. But for the rest of the region, we've had extremely low runoff since 2019. This map here shows the water supply outlook for June 1st, 2020, that's published by the Colorado Basin River Forecast Center. So while this is a forecast rather than the actual water supply that occurred, the June 1st forecast is very close to what the actual amount of water that flows through the rivers is in a given year. And you don't need to understand the whole map, but know that orange, red, and brown mean very low runoff. Brown is less than 50% runoff. Orange is 60 to 70% runoff. And in fact, during the 2020 water year, the Dolores, the Duchesne, the Gunnison, the Provo, the Sevier, the San Juan, and the Weber River basins all saw less than 50% of normal runoff. Now, if you go to just this past water year, the outlook and the actual water supply was even bleaker. For nearly the entirety of the Upper Colorado River Basin, the Great Basin, and the Virgin River Basin in southern Utah, runoff was less than 50% of average. And in fact, even varied from as little as 8% in some river basins. And as sort of an indicator of the entire basin, the inflow to Lake Powell represents flow from most of the Upper Colorado River Basin. And that inflow to Powell had 28% of its normal runoff entering the lake. Also of note, this summer, in thinking about this impact of multi-year drought, the federal government issued emergency water releases from Upper Colorado River Basin reservoirs to put more water in Lake Powell and Lake Mead, which are getting extremely low. Extra water was released from Flaming Gorge Reservoir in Utah and Wyoming, and Blue Mesa and Navajo reservoirs in Colorado. In early 2019, all of the reservoirs in the region were completely full after a very good 2019 water year. Reservoirs now are much lower, but considering how severe the drought has been, there still is reasonable storage in a lot of the regional reservoirs. In Colorado, reservoirs are 74% of their normal levels for this time of year and 50% full. And in Utah, it's a little bit better of a story. The reservoirs are 86% of median and 60% full. So now let's talk about some very visible impacts of drought. And one of these is impacts to Lake Powell. In August of this summer, Lake Powell reached its lowest elevation since the reservoir filled in 1963. It first filled in the early 1980s. Right now, the amount of water storage in Lake Powell is less than 30% of its capacity. So this figure here shows elevations of Lake Powell as it's fluctuated from when it began filling in 1965, to current. And right now, Lake Powell is at its lowest elevation ever of 3,543 feet above sea level. And this is nearly 160 feet lower than the reservoir is when it's completely full. Now, what's the future of Lake Powell? At least the medium-term future. So the U.S. Bureau of Reclamation puts out 2-year projections of how much water will be stored in Lake Powell, what its elevation will be. And this figure here shows what the projections are for elevations of Lake Powell over the coming 2 years. The lake is expected to continue to drop until runoff begins in April of 2022, dropping another 20 feet or so to 25 feet above sea level. And now these projections, there's 3 different projections, a best case scenario, the highest it could be, a middle of the road kind of, average, a most likely scenario is how they put it. And then the lowest projection that they have. And under this lowest projection in the red circle there, the lake hits minimum power pool, which is 3,490 feet above sea level by early 2023. And this is significant because that's the level that if the lake goes below that, Glen Canyon Dam can no longer generate power, which creates a whole nother chain of problems if that happens. I want to point out that in 2022, there begins a process to renegotiate the interim guidelines of the Colorado River Compact. Colorado River Compact is an interstate agreement that governs how water is distributed and moved around throughout the Colorado River Basin. And the specific parts of it that are going to be renegotiated have a lot to do with how the reservoirs throughout the basin are managed. And finally, just some specific impacts to Lake Powell itself. This is an area that's used by as many as several to 5 million visitors a year visit the Lake Powell region. And one of the big sources of recreation there is going out in the lake by boat. And many of the boat ramps were closed this summer. The permanent boat ramps are now, many of them sit, 30, 50, 80 feet above the level of the water. And there's temporary boat ramps that have been built, but it limits the amount and size of crafts that can be put into the water. So another impact of drought in our region, another one of these very just visible impacts is the Great Salt Lake. The Great Salt Lake is the largest lake in the United States outside of the Great Lakes. And it reached its lowest elevation this summer as well, in August of this summer. This figure here shows data that's been collected all the way back to 1850 on the elevation of the Great Salt Lake. And you can see it varies from year to year and over longer cyclical trends. And currently, its elevation is 4,190 feet, which is just a little bit lower than the previous low, which was reached in 1963. And it's the all-time high elevation throughout the historical period was about 20 feet higher than it is now. So I want to point out that the Great Salt Lake, since it's a terminal lake, nothing flows out of it. It's essentially a big evaporation pond. And its elevation, and then therefore its size, because the Great Salt Lake is in a very shallow basin. It's a very shallow lake. So as it changes in elevation, its size changes very quickly as well. And the elevation and size of the lake varies with climate. And this is kind of what we're seeing in this figure here with annual fluctuations and these longer cyclical fluctuations. And the area of Great Salt Lake, from its high elevation in 1987 to its low elevation now, that area varies by a factor of 2.5. And currently there's about 1,400 square miles of salt flats that are exposed. And this has some significance when you think about potential impacts of a low-grade salt lake. These salt flats, they don't have any vegetation on them. So the material, the soil in those salt flats can be mobilized by the wind and can cause dust pollution downwind. There's other terminal lakes in our country, most notably Owens Lake, that when it dried up, it caused severe air pollution problems to the local area and even a broader region. The big difference between Owens Lake and the Great Salt Lake is that we have a couple million people that live around Great Salt Lake, whereas Owens Lake is in a very rural area. So there's this potential risk to increase pollution in an area where air pollution is already a concern in both summer and winter in the Wasatch Front of Utah. There's also risk to wildlife with low elevations of the Great Salt Lake, drying of wetlands that are vital for a vital migratory bird stopover. There's also a brine shrimp industry on the lake, and we're getting to levels of elevation of the lake, temperatures, and salinity that may significantly start to affect the viability of that brine shrimp industry. So I briefly touched on dust pollution that might come as a result of a low Great Salt Lake and drought. Well, I want to talk now about wildfire smoke and air pollution that's caused by wildfire smoke. While we didn't see any major fires in Colorado, Utah, or Wyoming this summer, certainly nothing like summer of 2020, there were some very, very large fires that were burning in California and Oregon this year. And this figure and the next few figures show a map of near surface smoke concentrations on different days. So the purple represents extremely unhealthy smoke concentrations, and reds and oranges are still unhealthy, and yellow and green is lower concentrations of smoke, but still present. And I want to relate the smoke that's being blown across the country to air quality within our region. And I'm going to express that using AQI, or the air quality index. And in some of these slides, I'm going to show the AQI specifically for particulate matter. So that's very, very small dust particles from the smoke, and for ozone, which isn't directly related to smoke. So on August 8th, throughout Utah, AQI was in the unhealthy range, from the Wasatch Front, about 100 to 130, even to more rural areas like out in the Uinta Basin near Vernal and down near Zion National Park in southern Utah. Colorado also had very high AQI for particulate matter, as high as nearly 160 in Denver. And it was also very high in more rural areas like Grand Junction and even Glenwood Springs, where it was 134. Particulate matter air quality was not nearly as bad in Wyoming, but still elevated in the 75 to 100 range, so approaching unhealthy. And I want to point out that I'm going to just show 3 cases of smoke blowing across our region. But for much of the region, especially in Utah and western Wyoming, there were weeks on end without smoke. I unfortunately don't have data of like how many days smoke was visible, but for much of July and August in Utah, western Wyoming, western Colorado, there was smoke around pretty much all summer. So now this figure looks at near surface smoke concentrations from July 12th of this summer. And the way the map is, you can see these very distinct smoke plumes coming from the Bootleg Fire in Southern Oregon and the Dixie Fire. And I want to point out that you can see the smoke concentrations are very high, just a little bit west of those fires. Then it kind of goes away, and then the smoke rematerializes. What's happening is the smoke near the surface is being carried up into higher levels of the atmosphere, and then it's descending back down to near the ground surface. So I'm going to focus specifically not so much on particulate matter pollution, but ozone pollution in Colorado and Utah, and why that's not directly related to wildfire smoke. So but it is very much indirectly enhanced by wildfire smoke. So ozone, unlike particulate matter, is not a primary pollutant. It's what's called a secondary pollutant. This means that ozone is formed through chemical reactions in our atmosphere. And you need both volatile organic compounds, which are present in high concentrations in wildfire smoke, and nitrogen gases, which are not present in wildfire smoke, but are present in urban areas. So often when wildfire smoke comes in contact with an urban environment, this can create conditions where ozone can be extremely high and much higher than it would be if the wildfire smoke were not present. So in Utah, both in the northern Wasatch Front and even in rural Price, Utah, which is in central Utah, there was unhealthy ozone air quality. And in Salt Lake City, it was extremely unhealthy, approaching 200 for AQI. We also saw high ozone, poor ozone air quality in Cheyenne, Wyoming, and throughout several locations in Colorado, along the Front Range, and even in the Grand Junction area. And it was nearly, ozone AQI was nearly 200 in Denver. So extremely poor air quality happened on that day. The final instance of how wildfire smoke from the West Coast is affecting our region, I want to bring about a case where we see not just particulate matter pollution, not just ozone pollution, but the coincidence of both of these pollutants at the same time, at least in Utah. And this creates a situation that is even worse for human health, because you have two air pollutants that might be causing health problems. And you can see there was extensive smoke over the entire western, northwestern portion of the United States, and especially most of Utah and western and northern Wyoming. So particulate matter air pollution was quite bad on this day, ranging from a little over 100 in parts of Utah to as high as over 140 in Sheridan, Wyoming. Now, while air pollution was in the unhealthy range for particulate matter along the Wasatch Front in Utah, simultaneously, it was extremely bad for ozone at the same time. So this is one of these cases where there is, you have an initial pollutant of particulate matter, which is dangerous for human health. And then the presence of other gases within that wildfire smoke enhances the formation of ozone, also creating that air pollution problem on that day. So the final thing I want to say about air quality is just looking at specifically at ozone across the region. So ozone is a pollutant that's monitored by the Environmental Protection Agency, and there's a specific standard for ozone that states are supposed to meet that standard. And the standard for ozone is 70 parts per billion. That's the concentration averaged over 8 hours. And I'm going to show the number of days that standard, that 70 parts per billion, was exceeded across our region. So on the Wasatch Front, there were over 20 days in Salt Lake City with very high ozone. This is an extremely bad ozone year for the Wasatch Front, and 10 to 15 at other locations along the Wasatch Front. Ozone pollution was similarly bad along the Front Range of Colorado, with 16 days exceeding the standard in Fort Collins to nearly 30 days in Boulder. And this final batch of sites I want to point out, because these are more unique sites. All of these are in locations that aren't really in a very strong urban environment. They're in smaller cities throughout the region, places like Cedar City, Utah, St. George, Vernal, Price. These are all very small cities. And there was even in Glenwood Springs, there was one day that didn't meet the ozone standard. So these are cases where they're very challenging air pollution problems, because in those locations, there's not really much that they could do from a regulation standpoint to clean up that air pollution, because a lot of the problem is being caused or enhanced by the wildfire smoke that's drifting from further west. So moving from drought and wildfire, well, we did get the opposite side of that climatological coin this year too. We saw some very heavy rains throughout our region, especially in July and August. There was a very strong North American monsoon this year, the strongest we've seen in quite a few years. And in July, so the next couple of figures here show percent normal of precipitation for each month, in this case, July. And the purples represent 200 to 400% normal precipitation. Blue is 150 to 200%. And you can see in July that much of Utah saw well above average precipitation, especially in southwestern Utah. July, that North American monsoon shifted a bit further north, and large areas of Utah, nearly half the state, saw over 200% of normal precipitation. And some areas in the Great Salt Lake Basin in central Utah that saw over 400% of normal monthly precipitation. This extended into western Wyoming and a little bit into western Colorado. And then finally, outside of the summer period, October was extremely wet across our region too. And I do want to point out that this wet pattern that was caused in October was not really so much from the North American monsoon. You can see a wide swath of purples extending from California across Nevada, northern Utah, and into Idaho and Wyoming. A lot of that had to do with a single extremely strong atmospheric river event that came through in late October. Another thing I want to point out is that all of our region experienced elevated rainfall, except eastern Colorado and the Front Range of Colorado. That region missed out from these rains for pretty much this entire period. We saw record wet weather in Utah. This figure shows precipitation by percentile for August 2021. There were 120 daily precipitation records in Utah during August. There was a very active monsoonal pattern on August 1st through 2nd, and again, August 18th through 19th. We saw some all-time precipitation records set, mostly in central Utah and Hatch, Scipio, and Delta, ranging from nearly 3 inches to over 4 inches in a day. While there was not much damage from flash flooding, there were in some locations, but there was extensive flash flooding in some of the canyon regions of southern Utah, especially in the remote Lake Powell region. And I want to point out that in the foothills of the Wasatch in central and northern Utah, we saw record wet August, those dark green colors. So while Colorado did not receive quite as much precipitation compared to average monthly precipitation as Utah and Wyoming did, there were some severe flash flooding events that happened in Utah primarily during July and into August. And this was really an interaction of wildfire the previous year in 2020 and heavy rainfall events that happened in July and August. There were 2 events in particular that were particularly severe. One was a debris flow that came down the Cameron Peak fire scar in northern Colorado, down Black Hollow and into the Cache La Poudre River. This ultimately caused 4 fatalities and destroyed several homes. There were also many debris flows in Glenwood Canyon that flowed down the Grizzly Gulch burn scar. So first, I just want to talk a little bit about the Black Hollow debris flow. The star here shows where the debris flow occurred in Rustic, Colorado, which is just a bit west of Fort Collins. On July 20th, heavy rainfall, about 1 inch of rainfall, which is not a very extreme event, but it's a heavy rainfall, triggered a debris flow that flowed down a small drainage, Black Hollow, into Rustic and into the Cache La Poudre River. This debris flow flowed right through a small community where several cabins were located, destroying 5 cabins. In one of those cabins, there were 4 people inside when the debris flow hit. 3 of those were killed, and 1 person is presumed dead and is still missing. These debris flows also closed Colorado Route 14 in 6 different places from several debris flows. There were also severe debris flows and mudslides in Glenwood Canyon. Glenwood Canyon, the Colorado River flows through Glenwood Canyon, and Interstate 70, a major east-west artery in our region, travels right along the Colorado River. Several debris flows closed I-70 multiple times in July and August of this year. The largest of these events occurred on July 29th, and this caused an extended closure of Interstate 70. It buried the highway under 6 to 10 feet of debris and affected a 1.5 mile stretch of highway. On one weekend alone, 600 tons of debris was removed from the interstate. The state of Colorado has asked the federal government for $116 million to repair damages to the interstate and to build resiliency against future events. And this really severely disrupted regional transportation and shipping throughout the region that has already been disrupted from supply chain issues associated with COVID. So to wrap up, I want to talk about the convergence of climate hazards that happened in 2021. We saw not just one type of climate hazard, not just in one location, but we saw multiple different climate hazards, multiple extreme events that happened throughout the region. And the occurrence of these climate hazards are related. They're not independent. I want to introduce the concept of compound hazards. And what I mean by that is that often the occurrence of one hazard can create conditions for another hazard. And that may even create conditions again for another climate hazard to occur. That none of these climate hazards acts in isolation, that many of them interact with one another and change conditions, leading to conditions that can make the risk of another climate hazard all the more likely. And climate change interacts with all of these climate hazards as temperatures get hotter, as precipitation regimes change, as wildfire frequency changes. And I just want to give some examples of sort of this chain of events that can happen with compound hazards. Extreme temperatures and low precipitation ultimately can lead to drought. Drought can increase wildfire risk, and then that in turn increases flash flooding risk on the burn scars left behind from wildfires. Wildfires, even in areas distant from our region, can lead to severe air quality issues. And I want to stress that climate change, while it doesn't cause any of these specific climate hazards, it acts as an amplifier to many of these climate hazards. Climate change more directly impacts some hazards compared to others. For example, temperatures are warming. Extreme temperature events are directly linked to drought. However, other climate events such as flash flooding and debris flows are not as directly connected, meaning we can't attribute a single flash flooding event, a single thunderstorm, or even a single wildfire to climate change. But climate change makes these events more likely to happen. It makes them more likely to be more severe, to have a longer duration, and to occur in larger geographic areas. I also want to point out that this concept of compound hazards is not isolated to just climate and weather events. Other events can cause some of these climate hazards to have worse impacts. Things like the COVID pandemic. An example can be the stress supply chain that was caused by the COVID pandemic. And then, at least on a regional basis, the closing of Interstate 70 disrupted regional transportation, the cost of goods, and the availability of goods. Now, the final thing I want to leave you is I want to leave you on a little bit more of a positive note, or at least a little bit more of an interesting note, rather than just flooding and destruction and landscapes drying up. So these two side-by-side pictures are taken from a place called Cathedral in the Desert. This is a beautiful little side canyon that has been underwater in Lake Powell and the Escalante arm of Lake Powell for most of the time that Lake Powell has existed. This came out from under the floor of this little desert canyon, came out from the water in during winter, late winter of 2021. And these two pictures, one comes from April 2021, and you can see that you can still see the lake right there. It's receded from back where this little waterfall is, but it's still visible. And then in October 2021, the obvious change is that the lake is no longer there. But I also want to point out that a massive amount of sediment, which was deposited by the lake when the lake was there, was flushed out into the lake and downstream from a very large flash flood that occurred on August 1st. So here's a case where you have drought, which is drought, which is causing Lake Powell to lower, which is a challenge for water supply, problems for water management. However, there's this landscape that was once buried under the lake that's now visible. And it's also being cleaned out by nature as you're getting these flash flooding events down through. And this particular flash flooding event carried a massive amount of sediment out of this small side canyon. You can see me standing there for reference and elevation, and about 15 or 18 feet of sediment was removed from the floor of this waterfall. And just to leave you with maybe a little bit of a moment of zen, of just a little bit wider view of this landscape, not really specifically related to extreme events of summer 2021, but thought I'd leave with a pretty picture. And with that, I'd be happy to answer any questions that you may have.
Awesome. Well, thank you so much, Seth, for that fantastic presentation and for all the beautiful pictures and images and interesting ones, even when they weren't quite so calming. And thanks to those of you who've already submitted your questions through the Q&A box. Please keep those coming. We're going to start putting them to Seth. So Seth, the first question is, did the wet or like that precipitation increase kind of in the middle and end of the summer, did it help recover any significant soil moisture or stream flows?
Yeah, that's a great question. So I guess I'll start by saying those rains did not get us out of the drought. However, those rains did improve drought conditions. It didn't really remove drought anywhere because a lot of these areas, especially in Utah, they're in the worst they had been in the worst categories of drought possible prior to these rains coming. So prior to the rainfall coming in July, there were many regional rivers, especially in Utah and Western Colorado, that stream flows were near or at all-time record lows. And all of the rain in July and August and now in October has brought most regional stream flows up to kind of the low end of the normal range now. So stream flows have recovered some. Talking specifically about soil moisture has recovered quite a bit. In large areas of the region, we were seeing record low soil moistures in July. And in fact, if you look at soil moisture at higher elevation sites in Utah, in the SNOTEL network that monitors snow water equivalent, there's soil moisture monitors there as well. And in July, statewide average of SNOTEL soil moisture went from record low in July to several points in August and October where record highs were reached. So going into this water year, where soil moisture conditions look much better, which is promising, at least for a more efficient runoff.
Great, thank you so much. The next question is, do we have any information regarding the recurrence interval or the probability for the Glenwood Canyon events? And a follow-up to that is a question about the forcings and interaction of conditions that may lead to these record events in Glenwood Canyon moving forward.
Well, so it's kind of hard to talk about recurrence intervals for Glenwood Canyon in the sense that because we're dealing with a wildfire burn scar. So not that big of a rainfall event is going to trigger a mudslide. It could be even as little as a half-inch rainfall event could trigger a pretty significant mudslide. So really kind of what that area needs for the next several to many years, it's going to be an ongoing problem. It's going to be, those soils are extremely unstable, and where the highway is, it's directly in the path of those debris flows between the slope and the river. So I can't really say about the recurrence intervals on those, just because the conditions changed significantly in 2020. I would say that it's likely, and Colorado Department of Transportation is preparing for these events to happen very frequently. I would say that travel will continue to be disrupted when there's thunderstorm events, and I-70 will probably just be preemptively closed during many of these thunderstorm events.
Yeah, and so I think that you had mentioned, but that was the site of, was it the second or third largest fire in Colorado state history? Was that
No, the Grizzly
Glenwood
Gulch
Canyon?
fire was a smaller fire.
Oh,
I
it
mean,
was.
compared to
Okay.
200,000, it was 32,000 acres. It's just that it burned the slopes directly above the highway in Glenwood Canyon. So it's just in a specifically really, really bad spot for maintaining that infrastructure.
Oh, great. Thank you for that clarification. I'm looking through the other questions. Let me see what we've got. So it says we haven't talked about groundwater depletion. Do you have any thoughts on the amount of time that it might take to get back to normal groundwater levels and base flow levels in streams after these severe droughts?
Well, it really depends upon what climate does. So, one estimate here, I can give you one, throw out a few numbers there. The Utah Climate Center just did some calculations and published them, not in peer-reviewed literature, but just as kind of an exercise on what it would take Utah to get out of this drought. And they estimated that having a snow year that was somewhere around 160% of normal would get the Wasatch Mountains in northern Utah out of the drought that we're in right now. In terms of groundwater levels, I mean, that interacts with how much withdrawal is happening. So, and depending upon what the local geology is, there's different rates of aquifer recharge, and that's really variable between regions. Having wetter soil moistures right now than we have had in quite a few years, this sets conditions up for recovery from drought. Still, the climate and weather that we're going to see this winter will ultimately determine whether the drought we're in continues or whether we really keep moving towards recovery from this drought. But it will take a couple years of normal precipitation to emerge from this drought.
All right. So we have one interesting question about an article from Gizmodo that was arguing about draining Lake Powell and combining the water into Lake Mead. So basically consolidate all of that, reduce evaporation, and try to get it closer to the folks that maybe need it. So that's a little bit of a curveball, but Seth, what do you think?
Sure. Well, so I'm not a water policy guy, so I'm not going to make specific recommendations on that. I can talk a little bit about the climate though. I know that evaporation. So you've been thinking about climate change. Certainly having two big puddles of water, you're going to evaporate more water than having one big puddle of water. That said, evaporation from Lake Powell, I don't have numbers right in front of me, but it's not as dramatic as one might think, given how hot of an environment it is down there. Lake Powell is relatively deep, so rather than it being a big, wide evaporation basin like the Great Salt Lake, it's deep and narrow. So it is, in that sense, it's more resilient against drought and evaporation specifically. Now, in terms of policy decisions, I would say that the 2022 renegotiations of the Colorado River Compact are a big part of that is going to be dam operations and how the reservoirs are managed. And I would have to imagine that lots of different options are going to be considered. And I would say that it seems obvious that if the drought continues to a point that both reservoirs are in danger of not generating any electricity through their dam, then economics might dictate some action there. But right now it doesn't look likely that in the next 2 years that both reservoirs are going to reach that level. So not a direct answer, but some information around that issue.
Yeah, and as you said, water policy is always such a hot topic in our part of the country.
Yeah.
So thank you for that. So another question, is there any data about how long this drought might be expected to last? current one that we're in?
Well, I mean, everybody wants a crystal ball to, find out how much it's going to rain this year, and next year and the year after. I can say a couple things about that. One, things are looking better at this exact moment because soil moistures are wet. We've had some recharge of soil moistures pretty much regionally, with the exception of eastern Colorado. Soil moistures are looking much better than they have in many years going into the snow-covered season. This year's a La Nina year, so the ENSO phase is in a negative phase. Ocean water temperatures in the Eastern Pacific are colder than normal, so we have a La Nina. Typically, La Nina brings more precipitation to the northwestern United States, less precipitation to the southwestern United States. So a large portion of the Colorado River Basin, the upper Colorado and the lower Colorado, are in a zone that would be expected, that there's a higher probability of below average precipitation. More northerly places in the basin, like northern Wyoming and even the upper Green River Basin, there's a slight increase. There's an increase in probability for above average precipitation. So I would say odds are in favor this year overall, this winter, for it to be a below average snowfall for the Colorado Basin as a whole. And that varies regionally, but just looking at ENSO, it's likely that it's more likely than not that it will be a below average year. And unfortunately, that's about as far out as we can go with predicting precipitation and drought. That's kind of, in terms of, climate forecast, weather forecasting, there's this big gap between about 14 days of weather forecasting and looking at climate models 5 or 10 years from now. That 2 weeks to 9 years, there's not really much we can say about it. We can sometimes say something about these seasonal forecasts, thinking about 3 to 6 months when factoring in climate phenomenon like ENSO, El Nino, La Nina, but there's kind of a gap in our ability to predict weather between, weather a couple of weeks out and climate 10 years out.
Great. Thank you so much, Seth. And so that's about all of the time that we have for today. So if you have additional questions, please feel free to reach out to us. Thank you all so much for joining today's webinar. And to Seth, again, another big thank you for your great presentation and for fielding all of these questions. Remember, we'll also be posting a recording of this webinar on our website at Western Water, and we'll send you the link when it's posted. And in the meantime, again, please feel free to reach out to any of us if you'd like to keep the conversation going. You can email us at the general Western Water email, which is wwa@colorado.edu, or you can email Seth directly at wwa.arens@gmail.com. And I believe you have those posted in your slides too. Yes. Perfect.
The slide that's still visible has that. Yes.
Yeah, thank you so much. So thank you, everyone, and have a good rest of your day.
Thanks, everyone. Have a good afternoon.